Our speaker tonight is Mrs. Jean Williams, a member of our math department. Mrs. Williams is married to Jerry, and they have 6 children, 4 sons and 2 daughters. Many of you probably remember her son Sam, who graduated from the academy last spring. Mrs. Williams is very excited because she's going to be a grandmother. One of her other sons and daughter are expecting a baby. Mrs. Williams graduated from Archbishop Brady High School in West St. Paul. She attended St. Catherine's and graduated with a bachelor's degree in math and philosophy. She earned her master's in educational leadership from the University of St. Thomas. Before coming to the academy, Mrs. Williams taught for 25 years at St. Agnes. She taught there for 5 years and then took a year off from teaching to work as an actuary. She discovered that business was not her deal, and so she returned to St. Agnes for another 20 years. This is her 12th year at St. Thomas Academy. She says she has taught every math class that can be taught at the high school level. Currently, she's teaching pre-calculus, advanced placement AB, and BC calculus. She has been instrumental in starting our CIS calculus class at the University of Minnesota. She has also been a math team advisor and, of course, leads the BC Calculus Glee Club. Mrs. Williams served in the National Guard for 3 years. She enjoys reading, baking, and traveling with her sisters. She's the recipient of the Meisner Award. When asked to share an interesting tidbit, Mrs. Williams said she has had her picture taken for 5 summers with every Peanuts statue on display in the Twin Cities. So we are very proud of Mrs. Williams and happy she's a member of our teaching staff. Please help me in welcoming her.
Dr. Misch, Dr. Heidelberger, administration and faculty, parents and families, and especially Eagle Award recipients. Thank you so much for the honor of addressing you at this very special event marking your academic accomplishments. I understand it's been quite a while since a math teacher has been in this position. Therefore, I'm going to take full advantage of the opportunity and talk about my favorite topic. There's no question asked more often in math class than, when am I ever going to use this? We feel that what goes on in the math classroom is very specific and narrow in scope, not very applicable to our everyday lives. I'm sure all of you have said, gee, I'm sure glad I learned that alternate interior angles of parallel lines cut by a transversal are congruent. I can use that so often in my future. I'm going to address the fundamental question concerning the relevance of math by channeling a book that was written by Robert Fulghum in 1989. The book is titled, All I Really Need to Know I Learned in Kindergarten. And the author makes a case that everything we need to be successful in life can be traced to the basics we are taught in kindergarten. Things like knowing how to share, not running with scissors, or waiting one's turn. So my apologies to my colleagues in the other departments, but I would like to propose that everything you need to know in life, you learn in math class. And because I'm a math teacher, and by definition a nerd, I'm honor-bound to number my points. Number 1, use a pencil. How many times have you heard that one? There's a reason we use a pencil. It has an eraser. We make mistakes. A pencil allows us to have do-overs in our work. If there is something wrong with what we have done, we erase the error and we begin again. In life, we also recognize there are times when we have to start again. In a sense, erase what we have done and correct the mistakes. We make errors in judgment, we act too quickly, we say something inappropriate, we listen to the wrong people. There are so many ways we can go wrong. It's important that we acknowledge the mistake, step back, and start over. In the math classroom, I'm rather glad we're not yet at the point where we do all our work on computers, because the act of erasing a mistake would lose some of its significance. It's true we could have those do-overs by simply hitting the delete key, but there is no sense, no evidence then that the mistake was ever made. When you erase something written in pencil, you still see a faint mark on the paper under your now correct work. It's important to remember that you have progressed. You have physical evidence that you learned from your mistakes and are now ready to build on the good ideas. Number 2, show your work, or to say it another way, justify your answers. We all know that when we're working on a math problem, it's rarely enough to simply put down the answer. It is a requirement to also show the steps we take to get to that answer. The idea is that you not only have the correct conclusion, but that you are able to defend it. You can explain to anyone exactly how you got from beginning to end and demonstrate that there are no flaws in your reasoning. Think how useful this sometimes annoying requirement is for us. The practice we get in laying out the logical patterns helps us to apply the techniques to other areas beyond the mathematical textbook. The ability we develop allows us to keep track of our thought processes. Are we making logical conclusions based on true statements? If we somehow come up with an incorrect result, we can go back and dismantle the pieces of our justification to find out where we went wrong. Then we can correct it, there's that eraser, and proceed again. What an important ability in our lives, to be able to justify our ideas and actions with logical reasoning. We are able to clarify our own thoughts and strengthen our positions. In doing so, we are much more able to explain ourselves to others, and even perhaps to convince them to agree with us. You really like to work out every day. You want your best friend, who's a bit of a couch potato, to share your enthusiasm for it. How do you convince him? You'd better have some reasons that seem logical to him. Or perhaps on the other side of the coin, a politician is attempting to convince you that his or her platform is the best. The art of recognizing logic in an argument enables us to accept or reject in an intelligent manner what the politician is proposing. 3, read the problem carefully. How many times do we look at the much maligned story problems and realize that the meat of the problem is buried in some extraneous information? 2 trains leave a platform a half hour apart. One is going to Schenectady and the other to Timbuktu. If one is being driven by Superman and the other by Batman, whose train will serve dinner at 6 p.m.? We have to sift through the language to determine what is necessary and then decide how it must be used in order to find the correct answer. Very few situations in life are straightforward, and much like our handling of the story problems, we have to sift through all this stuff and determine what is important before we attempt to work toward a solution. We often find that by focusing on only the appropriate issues, we are able to simplify the process and come to a satisfactory end. We are not being distracted by things that are irrelevant. 4, ask questions. What if you read a problem in your math book, or are listening to a presentation of a new idea, or are trying to follow the directions and you still don't get it? You ask for clarification or for another example. You are expected to come in for tutoring. Not every student understands every concept the first time, every time. The same is true in the real world. One of the most important things we can do for ourselves is recognize when we need help. There are times when it is imperative to seek the expertise and guidance of others. Whether it is just having a friend help you interpret the directions for assembling a piece of furniture from IKEA, or it's formally seeking the help of an academic mentor or medical professional, we recognize that we can't do everything on our own. The better we are able to ask questions, especially in new situations, the sooner we become comfortable. It also gets easier with practice. We begin to appreciate how much we benefit from everything we've learned with the help of others. 5, be creative. People are often surprised when they are told that creativity is important in studying mathematics. Math has the undeserved reputation of being boring and regimented. Perhaps it's because of that emphasis on logic that is inherent in math. However, logic and creativity are not mutually exclusive. The more difficult the problems become, the more important it is to look at them from different perspectives. Sometimes it's easier to come at them obliquely as opposed to head-on. Often there is more than one way to solve a problem, and we can use a different approach if the method we first tried seems too clumsy or complicated. In mathematics, we talk about proofs or solutions as being elegant. An elegant proof is one which produces a result in the most efficient, precise manner possible. Coming up with that elegant proof usually requires some creativity. Maybe instead of just writing an expression like x squared minus 6x, It becomes an easier problem to solve if we write it as x squared minus 6x plus 9 minus 9. See me later if you want to discuss that strategy. There are so many situations in life when we are asked to approach a problem creatively. Think, for example, of all the work that went into planning our terrific new Flynn Hall. If you were the person charged with the task of coming up with the design and then implementing it, how would you have approached it? I'm sure there were many challenges that had to be addressed here that would not have been an issue at another school. What solved a problem elsewhere may not have worked here. We have an amazing result that reflects the ability of many people to think creatively. As individuals, we look at our daily schedules, our daily challenges. Many of them are the same as those faced by others. However, what worked for someone else may not work for me. Maybe I'm older or younger. Maybe I have a different level of education. Maybe I have access to different technology or other resources. I can creatively apply my own unique perspective and skill set to get results. Just because someone else or everyone else has done it another way, that doesn't always mean it's the only way. 6, it's important to work well in groups. What if we each take our individual approaches and expertise and work together to solve a complex math problem? When students work in groups, the expectation is that there will be a discussion of best methods and appropriate formulas and so on. The whole group then submits a solution, and each member accepts equal responsibility and therefore also accepts the grade that is earned. Doesn't that sound a lot like the way things operate in general? A large number of businesses rely on the collaboration of many individual employees to accomplish their goals. We live in a world where we do not work in isolation. Even if we are scattered across the globe, we are able to have meetings and communicate instantaneously. The success or failure of a new enterprise is often attributed to the work done by a group of individuals as opposed to a single person. 7, and this one's kind of hard to swallow. Harder problems produce more satisfying results. Even though we sometimes dread the difficult problems and all the work that they entail, we are so proud of ourselves when we get through them. You are working on your math homework and are struggling with a question. You check your answer for maybe the 3rd or 4th time and finally get it right. What a great feeling. You have truly accomplished something far beyond a simple calculation, and you see the result of persistence and effort. In real life, when you cook a meal for the first time from scratch, how much better does it taste than something from a box? When you are able to build or paint or design or write something yourself instead of using something produced by another, how do you feel? It certainly requires more thought and effort on your part, but at the same time, you have a better understanding of and appreciation for your own capabilities. What about climbing a mountain, running a marathon, learning to play a musical instrument? There's a tremendous amount of training involved, but all those who put in the work will tell you it was worth every minute. 8, balance those equations. In an equation, the left side always has to have the same value as the right side. There is symmetry. There is balance. In fact, a lot of our work in math seems to be based on making sure we keep things the same on both sides of that equal sign. So many times we talk about the importance of maintaining balance in our lives. We can look at it from a psychological and emotional perspective, but I would say that the idea is the same as what we do in math. We have to make sure we don't overdo one part of our life at the expense of the other parts. We have to recognize what is important, learn to prioritize, and realize what it is that we can't fit into our lives. 9, don't forget the importance of humor. Okay, here's some old ones. Why is 6 afraid of 7? Because 7, 8, 9. Right? What did the 0 say to the 8? Nice belt. Get it? So, just as we see the need to be logical and precise, we also see the need to laugh, to reduce stress. We understand that humor can also help us step back and look at things in a new light. Have you seen that cartoon that shows 2 very befuddled professors standing in front of a blackboard that is covered with a very long, very complicated mathematics problem? The problem starts at the top of the board, and there's a conclusion at the bottom, but in the middle are the words, and then a miracle occurs. Humorous, right? I don't think anyone will deny that this need also extends beyond math class. Unless we can see the humor in our everyday situations, we are doomed to become victims. We don't all have to be comedians, but we do need to be able to recognize when laughter and joy will enable us and those around us to cope with a life that may otherwise be a drag. Finally, number 10, there has to be a God. Okay, so how do we learn that in math class? For one thing, I know it because I see my students praying really hard before a test. Since time immemorial, philosophers have attempted to prove or disprove the existence of God. One of the most compelling proofs for God is the order and design in the universe. The argument is that the complexity of nature and the obvious patterns that exist could not have occurred randomly. Even considering we are the result of a Big Bang, there must have been a supreme intelligence guiding the whole process. Nowhere do we see more clearly how order and design work than in mathematics. So much in nature can be expressed in mathematical formulas or concepts. Since the beginning of time, human beings have recognized the patterns, symmetry, and even the algebraic formulas that govern and explain the phenomena of the universe. It is interesting that the earliest philosophers were also mathematicians. Think of Pythagoras, for example. In 1623, Galileo wrote that the entire universe is written in the language of mathematics. And much more recently, the astrophysicist Mario Livio wrote a book titled, Is God a Mathematician? He states that it is mathematics that accurately describes and predicts the world around us. He reminds us that what is true in mathematics has always been true and will not change. It will always be true. Isn't that a fundamental attribute of God? So, in the end, there is something very significant about the relationship between math lessons and life lessons. It allows me to answer with confidence. When are you ever going to use this? Every day. Thank you.